Alright, hi guys, welcome to the last video of the set of series of sequences videos. Okay, our last topic here is sigma notation. So what is sigma notation? It's this thing over here. What was that? That was the capital letter sigma in Greek letters. Okay, let's try to figure out what sigma notation means. Okay, so we have this thing over here. What does this mean? So, first of all, the sigma notation means it's a sum. Okay, sum of what? We are summing from the first n, okay, which is when n equals to 1, and to the last n, which is when n equals to 4. And what is the expression we are given? N squared. So we'll put in n equals to 1, 2, 3, and 4. And as you can see here, we're just summing up 1 square plus 2 square plus 3 square plus 4 square. Seems simple enough, okay? Let's move on to the next example. So we are summing from n equals to 1 to infinity of square root n plus 2. So we have square root 3 plus square root 4 plus square root 5 all the way infinitely. Alright? Now let's take a look at some of the identities we may need to know. First of all, this identity. Okay? When a is a constant, when we sum everything up, we realize, okay, this is just the number of terms. We have n minus m plus 1. Alright? And then for this, we'll just times a. Okay? So that's the first identity. Next, since this whole thing is a sum, if we're summing up two different functions or two different expressions, then we can kind of just separate these expressions. Alright? And the final one is if there's a multiplicative constant inside the sigma notation, okay, for example, 2n squared here, this is just going to be equals to 2 times of the entire thing, right? This makes sense, right? Okay, now let's move on to the questions. Okay, we have two questions over here on the right, which we'll answer with two different answering techniques. Okay, for sigma notation, we have two ways of solving the question. Number one, by cancelling terms. And for number two is identifying an AP or GP. Okay, for the first one, we'll actually cancel out terms. So let's see how. Okay, if we try to evaluate the expression, we'll actually get root 5 over 4 minus root 1 over 4 plus root 9 over 4. And let's keep writing a bit more. Alright, so what do we do here? Let me just group them up. This is T1. Okay, this is T2. This is T3. Okay, and this is T100. Or just n equals to 100. Alright? So, what do we see here? Do we see any terms that can cancel out? We see that this root 5 over 4 and this negative root 5 over 4 actually cancel out. Similarly, this root 9 over 4 and this root 9 over 4 actually just cancel out. And we can continue repeating this, okay, where this root 13 over 4 actually cancels out with a root 13 over 4 somewhere over here. And if we repeat this enough, we'll realize that this will also cancel out with this, okay? Why is this so? We realize that the first part of the first term will be cancelled out with the second part of the next term, okay? So in this case, this will be the second part of T100 while we're cancelling out the first part of T99. Okay, but we realize in the end, this negative 1/4 stays and this root 401 over 4 stays because it doesn't cancel out with anything. So in the end, what this just gives us is root 401 over 4 minus 1/4. Okay, that's just your answer. The next one, we're going to solve with AP or GP. So what I like to do with sigma notation, as you can see over here, even in the first example, I like to list out the terms, okay? So what I'm going to do is, I'm going to list out the terms. Okay, so I've listed out some terms. So what is this? Is this an AP or GP? This is actually a GP, right? With common ratio equals to 2. Alright, recall that for a GP, Sn is just equals to T1, 1 minus r to the power n, over 1 minus r. Again, if you forgot this, this is in your formula booklet. Okay, so for this GP with r equals to 2, let's use this formula. First of all, n. What is n? If you realize here, there are actually 8 terms here. How do we know this? We'll use this over here, number of terms. Number of terms will just be n minus m plus 1, which is 10 minus 3 plus 1, and we get 8. Alright, so we know that n equals to 8. We can start. We can see that S8 is just equals to 8, because that's the first term, 1 minus 2 to the power n over 1 minus 2. Oops, sorry. This is not n, this is just 8, right? And if we calculate this out, we should get 2040. Okay, let's go on to our GDCs. Let's say we want to write sigma notation on the calculator. So I'm going to press the calculator, and then I'm going to press this button on the left over here. If you look at the GDC screen, then I'm going to press this sigma notation, and earlier we had n equals to 3. So I'm going to write n equals to 3, and then the upper bound is 10. Then what I have here is 2 to the power, if you look at where the power sign is, to the power of n. And I press enter. And I'll get 2040. Take note, if the question asks you to compute in the exact form, meaning like with square roots and everything, the GDC will give you a decimal, and that will not be correct. So again, if the question asks you to find an exact form, you cannot use the GDC for it. Alright, so we are done with series and sequences. Here's the summary sheet for series and sequences. Thank you so much for watching. I hope you enjoyed and learned something out of it.